Welcome to qnawire.
Okay, so this is kind of a tricky problem that's essentially about why you don't want to react a Grignard reagent in the presence of water, right? As I'm sure you're aware, to get to A, we're basically creating a Grignard reagent, right, by reacting an alkyl halide with magnesium and ether, which will give structure A. Okay. Now recall that Grignard reagents are extremely basic, right? Because another way we can conceptualize this is as having a lone pair and a negative charge on carbon and a positively charged magnesium bromide off to the side associated with it, right? So these are sort of two ways of drawing the same thing. Also recall that a structure like this is incredibly basic, right? And that is basically like saying that the corollary to the extreme basicity of a carbanion is like saying that if we put a proton on it, this is not at all acidic. It's really hard to remove this proton. And what that means for us is that if this Grignard reagent encounters a proton that's at all acidic, it's going to immediately abstract it, right? Which is basically just going to destroy our Grignard reagent. This is why we perform Grignard reactions under inert conditions, meaning no air, no water, anything like that. Okay, so this is A, right? This is structure A. What structure B is that we've taken A and we've reacted it with water. And that's exactly what I was just saying we don't want to do. The reason being is that this will abstract the proton from water almost immediately. To give us the following. Right? And then we've basically ruined our Grignard reagent, right? This is B. We went from having a somewhat useful alkyl halide to having just a regular old alkane, right? We don't really want to replace a bromine with a hydrogen for no reason. We basically just wasted all that effort by exposing our Grignard reagent to water.